Hello and welcome to another video on conditional probability. So we've done this problem in the past, but we just answered some different questions. So one thing I'd like to do is say that you can do these with Venn diagrams. Okay, you can do these with Venn diagrams, but another way to do it is to go ahead and make a contingency table. I like this way better. Okay, and I just started doing this. And I just kind of learned it from somebody else. And instead of messing with these Venn diagrams, because sometimes these could be confusing for conditional probabilities, contingency tables are pretty straightforward with contingency tables. So let's go ahead and show you how to set up the contingency table, and or we could call it a two-way table. Now, if you look at this, we have two categorical variables. We have two categorical variables. Okay, so let's put their living arrangements. I'm going to show you two ways to do this. So living arrangements. So L, the student, lives on campus. Okay, so what's the other option? It's either they live there or they don't live there. Okay, that's don't live. Let me use dashes here because I use dashes down here. That's they live here. The other category is whether they have the meal plan. Now, categorical variables, don't forget that they fall in categories. Okay, you can't get an average of if they fall in a meal plan or not. So this is going to be they have the meal plan, okay, or they don't have the meal plan. So I have a dash up there. So this is live, and with the little tilde thing or dash up there, that's not live. Okay, so let's make a table. Okay, and the bottom here will be our totals. You always want to fill in your totals. Okay, so one good way to do this is when you're dealing with percents, we could say, well, let's start off with 100 people. Because if you have 100 people, this would be our live. If you had 100 people, 56 of them live there, and 44 don't live there. Do y'all see that? So let's start off with, let me erase this real quick and make this a little more readable. This is your total here. It's your total. Okay, so let's look at this. Don't look at the meal. Okay, let's look at how many live there. See this 56 right here? Well, that 56 is the total of everybody that lives there. So you put that 56 over here. Okay, now let's look at the meal plan. Let's look at the meal plan, which is 62. So these are all the people. All these people here have the meal plan, and they have the meal plan. So 62 goes in here. Total, I have 100 people. Okay, well, how many live there and have the meal plan? They live there, and they have the meal plan. That goes right here in this intersection. So there's 42. Okay, now if you look, I think we could fill the rest of the table out. We can fill the rest of the table out, okay? Because this 42 plus what gives you 56. Okay, so that would be 14. 42 plus 14 is 56. Now I would say, now I'm going down here, at 42, okay, live there and have the meal plan. How many don't live there and have the meal plan? Okay, so that would be 20, because 42 plus 20 is 62. Okay, so now we need to fill in these numbers. Okay, let's fill in these numbers. So if this is 62, 8 up to 70, and so that would be 38. Okay, see how I did that? I just went from 62 to 70, which is 8, and then from 70 to 100 is 30, so it's 30 plus 8. So 56 to 100, 56 to 60 is 4, 60 to 100 is 40, so this would be 44. Okay, so you could do this two different ways, and then they should work both ways. So 20 plus what is 44? Okay, so 20 plus 20 is 40. 40 plus 4 is 4, so that would be 24. And you see this happens to match up here. So this is my contingency table. Now let's just make a note. We could do all these with decimals too, and this would be a 1. So this could be a 1, 0.44, 0.56. You could do all these in decimals also if you like. This could be a 0.2, 0.24, 0.14, 0.42. You have an example like that in your book, and you could change everything to hundreds if you want. You could move the decimal to the right on everything, because sometimes it's easier to deal with, like say you have 100 people. Okay, so now conditional probability. Now that we have this contingency table, these all should be very easy. This always goes in the denominator, the number, because this is the who that we're interested in. Okay, this, the number of who that we're interested in. I always think of that when this conditional. Okay, because this is the probability that you live on campus given you have a meal plan. What's the probability? So the first question I have to ask everybody is, who has a meal plan? How many have a meal plan? Okay, so if you look at this contingency table, what's the number of people that have a meal plan? Okay, the total number of people who have a meal plan. And that would be the sum of this column right here, which is 62. So I got 62. Now basically I'm only asking these 62 people. So I say out of these 62 people, how many of you live on campus? Because I'm actually saying what's the probability you live on campus given you have a meal plan? So I'd say, well, who has a meal plan? This many people have a meal plan. Out of this many people, 42 of them live on campus. So that's your answer. You could leave it like that, or you could throw it in a calculator. You could put it in a percent, however you want. Okay. So now let's do the next one. What's the probability that you don't live on the campus given you have a meal plan? So the meal plan's the important thing. That's in our denominator, so we have the same denominator. So it's going to be 62. Out of these 62 people, how many live off campus? 20 of them. Okay. Okay, now I'm going to switch it around a little bit. So instead of, I'm going to see how I flipped them. The L is on the left, now the L is on the right. So that makes it a little different because the who is different. I'm not interested in who has a meal plan anymore. I'm interested in how many people live on campus. So I'm saying, what's the probability of a meal plan given you live on campus? Given you live on campus. So I have to ask myself, okay, well, how many people live on campus? So take a look at this contingency table and how many people actually live on campus. So if you go to live here and don't worry about the meal plan, you know, kind of block the meal plan out. Forget about the meal plan and say, okay, well, 42 people and 14. So this is how many people that live on campus. So that's the only people I'm interested in. So out of these 56 people, how many live on campus? I'm sorry, out of these 56 people that live on campus, how many have the meal plan? Out of these 56 people, how many of these 56 people have the meal plan? So I go to this 56. This is no meal plan, this is meal plan. So that's 42. Okay? Okay. What's the probability that somebody doesn't? This is no meal, because it has this little sign right there, the little prime sign. What's the probability somebody doesn't have a meal plan given they live off campus? That's off campus. So I'm only interested in the people who live off campus. So here's off campus. Scan all the way over. I'm only interested in these 44 people. The first question I'd ask these people, because this is what I'm given, is how many of y'all live off campus out of your 100 people? 44? 44 live off campus? And then I would say raise your hand if you don't have the meal plan. Raise your hand if you don't have the meal plan. So that would be these people right here. So it would be 24 over 44. So these are all your answers. So that's how you do conditional probability. So as you can see, if you're able to set up a contingency table, it's not too difficult. Now with a Venn diagram, it's a little more difficult. Okay, so if you're interested in that, I'll show you how to do that. Okay, and if you're comfortable doing the contingency table, do the contingency table. Okay, so that's probably it on conditional probability. Okay, so hopefully you get it. It's very important. Next we're going to be doing Another formula for independence. A very nice way. Okay, so thanks for watching.